Hello, my name is Jack Morgan and this is a presentation for my game BlockSumVR. As you can see, I've got an overview of the VR app, BlockSumVR numeracy learning application. I have a walkthrough video which is narrated, which you can view on the actual PowerPoint presentation.
Hello, my name is Jack Morgan and I've created my project BlockSumVR. As you can see, the actual room type target number, adding replayability to the game. So no matter how many times you play the game, you'll have a different target value to reach. The aim is to take the cubes which are on the table and add them together to reach that target value. Whenever you click on the cube, there's a point and click in menus with the exit and start game. But I also have a victory menu which you will see once you actually complete the game. I'll be showing this at the end and above the target value, especially to create a better chance you have escaped. This is what happens when.
So, intentions. Whilst developing BlockSumVR, the main purpose and function intended was for it to be a valuable education tool, because of course it's a numeracy app, so I needed to avoid steering too much into the game side of it and keep it as an educational application. As you can see, I have given some research and I have quoted some other people's work. I mentioned here specifically over 74% of the participants found the simulation helpful for gaining a better understanding. Now I used this to apply to why I wanted to make a VR application for numeracy. See, I've also mentioned another one here, with long lags and simulated sickness. I will talk more about simulated sickness in terms of my game later on. So, key feature number one, so the ability to move cubes dynamically between two locations. So I've already kind of mentioned this. You got the cubes table, you got the values table. The cubes table is the start location. What you want to do is transfer the cubes that you want to use to make the final value, transfer them to the other table, which is the value table. So goes between locations, it goes from start to finish, finish to start. But there's a little catch in here which you might see on the slide. I said players thinking strategically, since the cubes cannot be reused after they have moved back, meaning you can subtract a cube from the value table, so that actually subtracts the value. However, in the process of that you lose the cube, which means that then you either have to look at it again and think, can I still make the number with my existing cubes that I've got, or do I need to press the restart button, which I have added on the wall. You see it plays a crucial role in enhancing the game's interaction mechanics. I think that it creates for a more fun learning experience. It also makes it more difficult, but you don't want it to be too easy. You need a player to really be involved, to actually think about what they're doing, so they don't just randomly pick numbers and hope for the best. Instead they think about it strategically and then they go, okay, this is what I'm going to do. So you see, satisfying tactical experience. I've described the feature. You see, I implemented a system that enables cubes to be moved to designated spots. I used placemats to do this. So I created these little white squares under tables and moved them between the locations. You also see my code for the move to table and move back to start. Implementation. I have talked about the implementation here for the two different methods. I won't talk about it in this presentation, but the information is on the slide. Key advanced feature number 2, which of course is the one which I said I'll talk about later, the description of the random number generating function. Now this is a very important part of the game, because not only does it add replayability through the fact that no matter how many times you play it, you'll get a different number each time you play it. So it's not like you press restart and you still got the same number to work out. You'll have a different one. It'll randomly generate it each time you go into a room. So per room, each room's got a different number, randomly generates. The same if you keep on playing over and over. So you see random number generating function that has an element of unpredictability and excitement. A generate target value is responsible for creating a new target value. The main aim was to create replayability, as I've already talked about. So you can see a little bit more detail into it. The function generates a random number or integer between 10 and 51 using random range 10 to 51. So that means that you'll randomly get a number between 10 and 51. So what is that, about 41 total numbers that you could randomly get? So it's quite a lot of replayability. So display update, after generating the target value, the function updates to the UI to reflect this number. Now this means above the door where you've got your target value, of course I needed to communicate what the random number generated is to that target display, so it displays it each time. I've also got debug logging, so that whenever you're testing the game you can see it in the debugs. So you see review of the HCI aspects issues in BlockSumVR, spatial awareness and navigation. Issue, players walking through walls, disrupted immersion and caused disorientation. So that was an issue I had, because I couldn't work out how to get the colliders working properly in VR because the lasers would always point through, so it caused some kind of motion sickness in a way. So the solution, I implemented teleportation mats to limit the movement. So instead of allowing the player to actually move around and control it, instead they use teleportation mats to teleport to different parts of the scene. Another thing is user interface design. So aspect UI elements need to be accessible and readable in 3D space. Now to describe this a little bit more, in VR it's very different because say in a PC game you got your UI, it's literally right there straight in front of you on your screen. In VR it's much more like real life where you can look all around you. So you need those UI elements to be positioned in a part of your screen or surroundings that are accessible and reachable. So you don't want them too close, you don't want too far, but you also don't want it left, right or behind you. You want it in the right position. So to get around this issue, say for the restart button, I created a restart button and actually put it on a wall in the room so the player could use teleportation mats and then could reach over to it and click it. For the menus, I created an open space and put it in front of them at the right distance so that everything fits within their view but doesn't look too close or too far away. Another thing is interaction feedback. So aspect clear feedback for players' actions is vital. And to do this, I implemented sound effects, placing cubes or reaching targets to enhance engagement. Now animations, I haven't actually implemented proper animations, but by this I'm more referring to how the cubes, you don't click it and it just suddenly appears on the other table. You click it and it moves across at a certain pace to the other table. So it's an animation in a way. So the meaning of that is that it gives you some kind of feedback. If a player can click on the cube and see it moving across to the other table, it'll allow them to see what's happened and what happens. Now for the sound, I have a couple of sounds. Whenever you click a cube, it makes a little clicking sound, which allows the user to know that they've actually clicked on the cube. Another thing is, if your current value goes above the target value, it makes a little bong sound, so that you know that you've gone above. Now of course there's also other sounds in the game, like whenever you escape you'll have a different soundtrack in your escape menu. There's a few different features of that implementation. Now comfort and motion sickness. Issues, sudden movements can cause discomfort or motion sickness. So again, back to the teleportation pads, restricted movement to teleportation reduces the likelihood of nausea, allowing players to focus on gameplay. Accessibility, ensuring the game is accessible to a broader audience is essential. The recommendation, provide customizable movements, teleportation versus walking to cater to different player needs. So back to the same point again, I added teleportation mats to get around this issue. So they are very important to the navigation in my game. Now onto the final slide, HCI evaluation of my app. So you can see navigation mechanism. The BlockSumVR navigation is primarily achieved through teleportation mats. I've already talked about this quite a lot. So next I'll go into the application of Nielsen's Heuristics. Visibility of system status. The game continuously displays the target value on the UI, ensuring players are always aware of their current objective. match between system and the real world. So the teleportation mechanic mimics real world movement patterns where players are accustomed to choosing how they navigate through the physical spaces. The user control and freedom, players can choose when to teleport, giving them an autonomy over their movement and exploration. Now you see, this is something that you wouldn't really think about when playing it, but it's very important. Instead of just automatically making the player teleport, you want them to teleport to specific locations where they want to teleport to. Say you got two different players, one person might choose to go to the left map, the other person might want to go to the right map. You don't want to restrict that, you want them to be able to explore and play it the way they want to so they can enjoy it. So you need to make sure that they can choose where they want to go. So error prevention, by limiting movement options, the game minimises potential navigation errors, enhancing overall user experience. So that's back to the same point about being able to go through walls. You can't do that if you're restricted to just teleportation maps. The application of Shneiderman's golden rules, strive for consistency. The teleportation system is consistently applied throughout the game, ensuring players quickly learn how to navigate and interact with the environment. Enable frequent users to use shortcuts. Advanced players can quickly teleport to different maps, speeding up gameplay and allowing them to focus on strategic decisions rather than navigation. So again, another reason why teleportation maps is so important in the game is that instead of worrying about how do I navigate, how do I move, where should I go, instead you go, okay, I got a teleportation map there, I should go there, straight there, and then you can get straight to the actual main part of the game. As again, it's a educational application. You want the main focus to be on the target value and working out how I can add up the numbers to reach that value. Enable frequent users to use shortcuts, I've already talked about that one. Provide feedback, immediate visual and auditory feedback occurs when players teleport or interact with objects, reinforcing their actions and making the interface more intuitive. Conclusion, the human-computer interaction evaluation of BlockSumVR demonstrates a thoughtful approach to navigation and user interaction by employing effective navigation strategies to place mats in the mats that you teleport between, and adhering to established usability principles. The game enhances player engagement and creates a more immersive experience. Addressing these HCI aspects ensures that players can enjoy the game comfortably and effectively. And now here's my references. So that is my game BlockSumVR. I hope that I gave a good explanation and I've answered all questions that you may have. Thank you.